NanoVapor Systems has developed a safe, simple, and time-effective technology for aircraft fuel cell degassing. This technology will change the competitive landscape in degassing operations and can reduce wing and center tank degassing time to an hour or less from historical norms of 24 to 36 hours. This document is designed for you as a technical advisory for the application of this breakthrough technology. The NVS degassing system is currently accepted by the FAA under the No Technical Objection Policy, or NTO, and will be published in forthcoming Boeing manuals for ground service operations. For verification, please contact your local Boeing service representative. The pictures shown in this document are real-time, live aircraft service operations. The client shown is Polar Air Cargo, and the technology has been used for servicing their fleet of Boeing 747-300 series aircraft for almost 3 years. Engine service, teardown reports, Boeing and FAA fuels analysis reports and field data can be provided on request. This degassing technology and applications training has been provided to the Royal Air Force and used in the Gulf region for 2 years. NanoVapor's presentation to NATO available on request. NanoVapor Systems developed the degassing technologies shown in this film for explosive gas mitigation in refineries, aircraft fuel tanks, and other confined space vessels. The commercial benefits to flight line service providers are twofold. Ground time for aircraft is costly, and thousands of dollars per hour are lost in productive time during the degassing process. Secondly, the application of NanoVapor technologies is the safest, fastest, and personnel and environment-friendly solution to the degassing process. The following is a step-by-step demonstration of NanoVapor technology used in the degassing of a Boeing 747 Series 300 aircraft at Prestwick Airport, Scotland, UK. It is always advised to calibrate gas meters before starting the process. Standard calibration procedure is shown here and is supplied as a kit by the meter manufacturer Gastech. The model used for this procedure is a GT402 multi-gas meter. In this procedure, both hatches of the single-wing tank are opened for an inlet and outlet. Standard fittings as shown will be used to secure both the inlet hose and the outlet hose. Using the Gastech GT402 meter with probe in the fuel cell to determine existing LEL and oxygen levels, the support personnel are able to log LEL mitigation over a given time period and to observe any unusual problems by first-hand observation. Standard safety protocols must be observed, including the upstream positioning of the NanoVapor unit at an appropriate distance from the work area. The NanoVapor unit in this film is an electrically driven model built for the Ministry of Defense. Typical aircraft degassing units would be all air drive and intrinsically safe. These are designed for explosive refinery atmospheres and the safest, most reliable units available. NanoVapor nomenclature for this unit is NanoVapor Intrinsically Safe Air Drive, NVISAD. All equipment is to be grounded, earthed, sequentially for standard safety protocols. Start with the grounding of the NVISAD unit. Then, ground the tank or vessel to the NVISAD unit. The delivery hose is then connected to the NVISAD unit. Do not connect to the tank vessel at this time. Connect outlet hose to the appropriate inlet on the tank, position hose downstream and at a safe distance from the degassing operation. Connect the hose to the tank outlet and mark appropriately with cones or signs to prevent trips or third-party entry to the work area. Start the NVISAD unit on slow flow control. Connect hose from unit to tank inlet portal. Bring the airflow up to operating level. Begin testing and recording of LEL and oxygen levels. When practical, take readings at lowest possible point. In this film, the readings are taken from the outlet hose. Real-time values indicate a 0 ppm LEL value in 28 minutes. This is even less than acceptable LEL values measured as a percentage of LEL considered safe. The introduction of a secondary chemistry nanozyme provides for the mitigation of the toxic but not flammable VOC compounds remaining in the tank. This procedure allows for rapid entry safely. Total elapsed time from start of treatment to man entry was under 1 hour. Acceptable LEL levels were achieved within 30 minutes. The NanoVapor ISAD unit runs on conventional compressors at 130 CFM at 90 psi. The blower provides airflow at 600 to 1,250 cubic feet per minute. Chemistry throughput is 150 milliliters to 1.5 liters per hour. Weight, 150 kilograms. Dimensions, 1,400 millimeter width, 900 millimeter depth, 110 millimeter height. All components are CE certified. The robust explosion-proof outer casing is made to Ministry of Defense standards using reinforced fiberglass with 316 stainless steel fittings. Anti-static, locking wheel systems, and integral and detachable eye-lift fittings provide easy mobility. The anti-static inclined fan was developed with Halifax Fans Limited and is driven by a gas-air motor. The unit offers dual air-driven measuring and chemistry monitoring capability for the use of multiple chemistry delivery with easy changeover. Nano-LEL is a safe, non-hazardous, non-petroleum-based product for decontaminating and degassing of closed-space vessels such as aircraft fuel tanks, storage tanks, refinery towers, and transport vessels. The formulation includes proprietary blended wetting agents, sequestrants, and encapsulation agents. Nano-LEL absorbs and encapsulates volatile petrochemicals at a submicron to submicron particle level interface and safely reduces their vapor pressure in enclosed spaces. This product is botanically derived and safe for the operator and the environment. MSDS provided on request. Nanozyme is a food-grade, organic, pure enzyme complex. The low molecular weight of Nanozyme allows for rapid dispersal and a long treatment-effective hang time. This product treats toxic petroleum-related VOCs and the MEK group. MSDS provided on request. At no time should this operation be left unattended. At no time should the NanoVapor unit be switched on or off while connected to the vessel. All internal safety and environmental protocols of the service provider are to be strictly observed. This advisory is not intended to replace, but only augment existing protocols. Time estimated for each fuel cell will vary according to several factors, for example, temperature, fuel residuals, and volume of cell. Typically, a well-prepared wing cell of 13 to 16,000 gallons will require 30 to 60 minutes to achieve a 0 LEL reading, versus historical methods requiring 24 to 36 hours. This will allow for a shorter work cycle for all operations and repairs.